Hello, guys. Welcome to another live stream. So today, once again, we'll be looking at three different, questions from the NeetCode 150. The goal of this is to, you know, solve those questions completely. Hopefully, yeah. So please, if you have any comments, please drop them in the comment sections. Feel free to ask me questions as I walk through the question. So I've taken the liberty of pasting down the question before time, so we don't take a lot of time like we did in the last um, live stream where we had to go between moving to lead code to get those questions and coming back to paste them here and we working on these questions, right? So in today's live stream, we'll be doing three different questions. As we move on, I would review each and every one of them. So starting with the first one, which is um, the top K frequent elements. I believe, it's a medium level question on lead code. So we'll be solving it here on Rust Playground. And like I said, if you have any questions, please feel free to drop them for me, and I'll be more than willing to respond. Yes, of course, it's the Rust Playground. Yes, that's the Rust Playground. So, so let's start. So, the first question we have here is, it says, given a vector of integers and an integer of k, return the k most frequent elements. You can return the answer in any order. All right. So, so first off, I'm going to comment out this block of code because that's what I'll be needing. Okay. Yeah. So, in the previous live stream, I would usually write this manually, but today I will not be doing that because we don't have a lot of time. I don't want to spend up to 2 hours like in the previous live stream where I spent up to 2 hours on the live stream. So today I want to keep it as short as possible, even if it's for like an hour, an hour 30 minutes the most, right? So that we can all end this and go about our different activities for today being Sunday. So how do we solve this? So the way I would think about this is, first of all, going through the question, right? So the question says we have an integer of arrays and we have a value k, right? So we have to return the element that occurred the most here, right? So for the first example that we have, which is this, we have one occurring 3 times, we have two occurring 2 times, and we have three occurring once. So we have to come up with a way in which we'll be able to, return the value of 1 and 2 because they are the ones that occurred the most, right? So thinking about this, how can we solve this? So there are two ways to solve this. The first way, the brute force approach of this is, has the time complexity of n log n because of the sorting algorithm that we'll use. Then the optimal solution is an O of n, which we can solve using the bucket sort. But I will not be solving the bucket sort solution. This is something that you can go ahead and try to solve it on your own. The reason for that is because it has a lot of Rust mechanics to it that if we focus on it, I feel like it will drain us away from the entire live stream. I would be more focused on writing Rust code than solving the problems. I don't know if that makes sense, but I'm going to go with the brute force solution for this, and I would also highlight, like I've mentioned, there is an optimal solution for this, which is using a bucket sort, that you could attempt on your own. But for the purpose of this live stream, we'll just be focusing on the brute force approach. So first of all, like I like to do in this sort of situations, I like to like visualize the problem, right? So like I mentioned, we have like something like this, right? So let's get this guy paste in here, right? So now it's simple. The question said we want we want to return the number that occurred the most. So in this case, we have one that has occurred 3 times, we have two that has occurred twice, and we have three that has occurred just once, right? So thinking about it, right? Thinking about it, um, how do we represent this, right? So the first thing that comes to mind is, what if we use something like an object, a hash map, right? A map, to represent that. So in that case, we would have something like this, where we use the value, we'll use the element as the value, and as the key, the element as the key, and the number of times it occurred as the value. So we'd have something like one occurred 3 times, we have two occurred 2 times, and would have three because it occurred once. So once we can do this, we can then go ahead and get something like, let's say, an array of tuples, right? So something like this, we can get something like this where we now have 1, 3. We have the other one 2 and 2, and we have the other one which is 3 and 1, right? So if we have this at the second stage, the next thing we can do is we can try to filter by, we can try to sort by, because of course this is going to come in, at random, right? So we can now sort by you know the values itself, right? So we can sort by the highest values itself. So at the end of the day, after sorting by the values, we'll now get the top k element, which is the first two in this case, because k here is 2, right? If it says 1, we'll just return, if k is 1, we'll just return the first one, which is this guy. So this is just like me trying to like trace through the problem to give a sense of what we are going to be doing shortly. So since I'll be using Rust, um, it's worthy to know that whatever it is that I'm doing in Rust, you can apply it to other languages. So at the end of the day, it's the concept that matters. But for this particular series, I've decided to use Rust for it. Um, you know. All right, so let's get into it. So the first thing we'll think about is we need a hash map, right? A map. So in Rust, we do that by importing it. So we say use std collections, and then in collections we have hash map. So we imported hash map. So now we want something like this, as we explained earlier on. So I'll delete this guy to make more space. So once that type of object, I also, okay, let me leave that other guy, the second guy. So here's what we want. So how do we achieve that? Okay, so we have an array, going back to, we have an array of, um, integers. So what we'll do is we'll look through this array, each and every one of them, and would insert into our object. If it is not there, if we don't have that value, we would pre-populate it. But if we have that value, we'll go ahead and we increment the the value itself, right? So if we don't have the key and the value, we would add it. But if we have the key, we'll go ahead and increment the value alone. That's basically what we are going to do. So in order to do this, we use a for loop. So for let me use I in length. So we do this, and now we are now moving through each and every one of those elements, right? But before we continue our map, we need to, so let's say mute. So say map. I know I need to declare the type that map will take, but for now, let's just move on. We'll come back to that. So we can say hash map new. All right, so we have this. We still have to come back and declare, but for now, let me just do that instead of. Oh, let's just do that. Let's not do that. Let's just. I'll come back to that. Okay, so now that we are moving through the elements in our array. So the next thing we go ahead to do is to say if let sum. So because we are interested in the values, so we say if let sum, want to get that value, right? We want to now check map. Want to check if the map has that key that we are looking for. It has maybe the key of one. Remember, we said we're going to use 1, 2, or 3 as the key. Then the number of occurrences as the value, right? So we say map.get mute, and then we'll pass the key into that place. So in this case, our key would be okay. This will be our key. So nums I. Okay. At this point, I don't think we do not need. So let's go like this first and see. So pass number, so reference to that number. Okay. So now, right, in order for us to be able to update this value, we have to dereference it, right? So the reference will say val, then we multiply and equal to is it multiplication? No, addition, sorry. So we have to add. We're adding 1. Remember, we are changing this value, right? This is the value, we are updating it, right? So the reason we can do that is because we are getting a mutable value from our map. So we're getting a mutable value from our map. If I did something like get, if I did not do get mute, I will not be able to do this, right? If I not do get mute, this is what I would do. I would come here and I will still do map dot insert, and I would have to pass, let's say num I, right? And I'll have to pass num I, and I'll pass 1. Sorry, val plus 1, which would not make sense because we still have to go back again and reinsert again. So we're doing double insertion. So that's not a very efficient code to write. So I'll comment that out and just continue with what we have. So we'll do else if we don't have that particular key, which is either 1, 2, or 3 in our map. We want to then insert it here. So we'll say map dot insert, and at this point we'll then say I and 1, right? So that's basically it. So at the end of the day, we want to, so this is let, this is supposed to be let map, let meet map. So before we move on to try and pass anything, let's just try to print to our console. So say print line, okay, so we'll say map. So we have this, and we'll just pass our map here. So let's see what happens when I run this. Of course, some things will break. We'll read the code and understand what broke. All right, as usual. So now we have, okay, so I'm supposed to add S because, yep, hold on. I did not expect that. Dot length, oh no. So I have to add dot length, and what I need here is, I'm checking for the key, so it's going to be I. Let me see. So let's run this again and see. All right. So if let sum, so it has to be the nums itself, like plural, because trying to get that value. Okay, so consider changing the binding from mute I32. Nope. Okay. binding type cannot assign to value, which is all right. Okay, so let's do something. Oh, okay, I see the issue. So we changed from get mute to get. So I forgot to change that back. Crazy. Let me do this. All right. So now, of course, like I said, you know, we okay. This is fine. I think we are fine. So, like I said, we wanted something like this, right? So this is what we wanted: a map, right, that shows the number of occurrences using the integers in our array, which is what we initially illustrated here, right? So we have one occurring three times, we have two occurring two times, and we have three occurring once, right? So if we run this multiple times, you will see that they would land in different sequences on our object or in our object, whatever. So if I run this again, you see, so it's okay. This time around, three comes second and one comes last, right? If I run it again, this time around, one is coming first. So they land at different positions at random, right? We cannot really say where they will really land at. So guys, please feel free to drop comments in the comments section, and ask questions if you have any questions that you want to ask. So the next thing we want to do now is we want to now turn our values, like we want to convert everything that we have into this, right? We want something like this, right? So in Rust it's called a vector of tuples, right? Or can say it's an array of tuples, right? So now how do we achieve this? So first of all, let me clean up this code. We don't need this guy. Like I said, we could do this, right? But it does not make sense because it's not like an optimal code, because at that point we are doing double insertion because we've already inserted at line 25. So we don't need this. So I'll take this out. Um, then I'll also take this out because we've already gotten what we want from that point. So now the only error we are seeing here is the fact that we are not using k yet. So Rust would warn you that we can add a prefix of underscore and blah blah blah, stuff like that. So if I go ahead and I add a prefix of underscore and I run it again, you see that error message goes away. Exactly. So we now have exactly the map object that we need. Like I said, this is a brute force approach. That is an optimal approach that you can use, that you could do using something like bucket sort, right? Anyways, let's continue. Yeah, thanks. I just corrected that the let keyword. So now, the next thing we're going to do is, like, we now have to ask ourselves, how do we achieve something like this, right? The reason why we are doing this is so that we'll be able to sort by the number of occurrences, right? We're able to sort by the number of occurrences, which is three or two or one, right? So now, how do we achieve that? So we can achieve this in Rust, like saying, let's say, for instance, um let's mute, because we know we are going to sort. So if we sort it, it's like mutates the position of those values. So we have to add our mute keyword. So what are we going to name this now? Let's just call it array. Very bad with variable names. So we'll take our map, and before we even move forward, we want to because in Rust you have to declare the type, right? You have to, in this kind of case, and I'll explain why. I think I explained that in my previous live stream, where I said, if in any situation whereby there are three situations where you have to, like, especially when you're using something like collect in Rust, right? You know you have to explicitly declare the type, right? So what I mean by this is, when I say map into iter, so I'm trying to convert this from the map to something else. So I'll just say collect. So I have to now declare where I want to, like, how I want the shape of that particular data to look like, right? In this case, I want it to be a vector of tuples. So I'll say I32 and close this, right? Let's see let's see what happens. So when I print again, let's see what we get at this point. Let's run this and see if I am correct. Okay, so um interesting. I see. Exactly. So yeah, so we have to, because it's an object, right? So this is what we want. So you can see that, using the into ether has converted it to this particular shape. So we now have this stuff, right, that we initially, spoke about, that this is, where we are heading to. So we want this shape of data, right? So now at this point, we now have, an array of tuples. So what that means is, because we have an array, we can now use, the sort method on it, right? We can now sort based on, the 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 elements in the tuple, that is the element at the index of one. So based on this guy, and this guy, right? So now the next thing we'll do here is to say array dot. So this is where it actually gets very sort of it gets sort of more Rust like, but it's something that you can still do in other languages. So we say sort, want to sort by this point, we want to sort by the second element, right? So at this point we'd say sort by um so sort by is a method that it takes a closure, right? And in that closure we say A and B, right? So now we want to, so B in this case, A in this case is 1, B in this case is 3. So since we are sorting by the element at the index of 1, which is in this our tuple is 3. So let me increase the size of this. I don't know if it's visible enough for you guys. All right. So since we want to sort by this, what we would now say is, what we would now do at this point would say B dot index of 1 dot compare. So there's something we call compare. We want to compare, and we'll say A dot index of 1, right? So if we do that and we run this code, let's see what happens. Expected an I32. Oh, I see. Yeah, so expected an I32. Yeah, found. So I think this has to be a reference. Let's run this again. Exactly. So we now have a stable sorted array that basically we are sorting by the second element in the tuple, right, at this point. So now we've been doing this all this while. We now have to now, since we've now sorted by, from, I think we're sorting from in is it descending order, right? So basically that's what this A or B. So if we swapped it and we sort and we did A dot one dot compare by B, so we'll be sorting in descending order. Is it? I think ascending order, I mean. So if I do this, you would see instead of starting from 3, which is the highest, to 2, which is the second to the highest, and 1, which is the last, it will swap. So we'll have 1 at the beginning, then we'll have 2, and we'll have 3 with the highest occurrence at the end. So let's just do this again, just for the purpose of learning. So if I run this, so you can automatically see that we now have 3 as the first one. So we have 3 which occurred once, we have 2 which occurred twice, and we have 1 which occurred 3 times. So we are now sorting it in ascending order. So we are going from the smallest to the highest. But if I swap it the other way around, we'll be going from the highest, that is in descending order. So we'll be going from the highest down to the lowest. So I'll just swap it back. So I'll say B and A. So I run this again, and now we have something that we can work with. So at this point, we're not yet done, right? So we now need a couple of things. First of all, we need to be able to take some elements from this array based on the value of k, right? Remember, our function takes two parameters, right? It takes the number of integers and k itself. So at this point, we can now go ahead and say, so we can say array dot eta dot. So at this point, there's something we call take. So take would take the value of k as usize. So this is a raw specific stuff. Usize, right? So I'll remove the underscore here because with that underscore we cannot run this function. So now we want to map, right? So we want to map, and remember, right? What is in our array is we have something like this. Is what we have in our array. We have an array of tuples. So at some point we have something like this, like 1 and 3, right? So now what we are doing is we are taking it like this. So we're iterating through this, and we are taking two of those elements or two of those tuples. That is these two first guys. So we take the second one. So this is what we would have here, right? So at this point, this is what we have. So what we are passing into our map is this and this, right? So what we would have in our map is something like this. The map takes a closure, and the closure of values, which the first one is going to be k, which is our key. We do not need we do not need the value. Remember, the question said we should return the value itself, right? The key itself, right? Not the value, sorry. So according to how we formatted our data in our objects, we used each of these number, the uniqueness of this number, as the key. So what we need to return is the key while checking for the most or the highest occurring, which is something that we've already done, I believe, at this line. So we sorted in ascending order, and now we are not taking it based on the highest ones, right, using the number of k that we passed into the function. So now, because we do not need the value for anything, we just pass an underscore there, right? So map, close the closure, and say k. And say dot collect. Let's see what happens. So I'll comment this out. I'll take this out, and now you might be wondering, what are we returning here? So another way we use collect again in Rust is, when it's at the end of the function, because now we are trying to return the value, we are trying to return an array, right? At that point, it takes whatever it is that we are returning, that is the return type of the function. So initially, if you remember, we had something like this where we did map.into_eta.collect. So we converted our map to become an array of tuples, so a vector of tuples, right? But in this case, we just want to return directly from this line, right? So we do not need to assign it to any variable or anything whatsoever. So you might be wondering, okay, we have a collect now, but we don't have something like this, right? What then happens? So at this point, this particular line now points to the return value of that function, right? So this function is returning a vector of i32s. So what that means is that this particular line of code will give us something like this. To give us something like this array of 1 and 2, right? So this guy automatically now points to what we are returning in this function, or what we expect the function to return, rather. So now if I run this function again, hopefully everything works fine with no errors. Exactly. So you can now see that we have 1 and 2 according to what the function expects us to to return. So once again, right, what we did here is very simple. So we created an object of key value pairs where we used each of these numbers as the key and the number of occurrences as the value, right? So every time we met every time we met the same key, we just incremented the value, the count of the value. And when we did not have a new key, we just went ahead and automatically inserted it to to the map, right? After that, we converted it to an array of tuples, so an array of tuples, and after that, we sorted it based on we sorted it in descending order, right? So from the highest to the lowest, and after that we then took the most occurring ones based on what the value of k is, which in this case is 2 from our equation. So if you take a look at this, which in this case is 2, and then we just did a simple map, and we returned that value automatically. So you can automatically see that this gives us 1 and 2. If we try another example, so let's try this one. Try this example. How many times? So you're supposed to return 2 also. So we're supposed to get, for this one, we're supposed to get 4 and 2. So I'll just clean this code out a little bit, make it clean this, take this out. We don't need it again. Also the print. And when we run this, so you can automatically see that now we now have 4 and 2, right? So that's basically how this is basically how to, and this is the example, and this is what you expect us to get. So like I said initially, this is like a brute force approach, and the reason it's brute force is because of the sort algorithm, which is an n log n time complexity. There is a faster approach which I will not be getting into. It's something that I challenge you guys to try and solve on your own. But the basic idea around that one is using something we call like the bucket sort, right? So that particular solution gives us, I think it gives us an O of n, right? We use 3 different for loops and all that to solve that. So that's it for the first problem, and this is top frequent elements. This is how you attempt to solve it. All right, so this is the first question. Then we'll go over to the second one. So the second one is basically the product of array except self. So I will just take this down, take this up. Basically I'll comment out everything here so it doesn't interfere with the new line of code that I'm about to write. Okay. All right, so we have this. I'll close this. Okay. All right. So the next question we have here is something we call the product of array except self. This is also a NeetCode medium question. Yeah. So in this one, we would try to solve both the brute force and the optimal solution. Right. So I'll try to be as fast as possible with this very one, but it's simple, right? So the question says, given a vector of integers, return a vector where each element at the index of I is the product of all numbers in the original vector except the one at the index of I. You must solve it without using division. So there is a caveat here, right? Solving this without using division, right? Because if we use division, it's going to pretty much be easy. So now we have an example. So we have 1, 2, 3, and 4, and it gives us 24, 12, 8, and 6. Right? So what this means from the title, product of array except self, is when we are at the index of 0, we want to get all the product of all these other numbers except 1 itself. So what that will mean is when we are at the position of 1, we want to get the I want to do something like 2 multiplied by 3 multiplied by 4, which is going to give us 24, right? So when we now move to the index of 1, we want to get the the value of 2 multiplied by 1 multiplied by 3 multiplied by 4, which is going to give us 12. And we get to the index of 2, we want the product of 1, 2, and 4, which is 1 multiplied by 2 multiplied by 4, which is going to give us 8. Right? We do that until we get to the last one, which is, so basically that's what the whole product stuff means, right? So when we get to the index of 3, which is 4, we want to get 1 multiplied by 2 multiplied by 3, which is going to give us 6. So that's basically what the product of array except self, right? So like I said, I will try as much as possible to go to do the brute force of this, which I believe is very simple. Then we'll try and do the optimal solution. The reason I did not do the optimal solution for the other one is because it's, like I said, it's sort of, goes away from the whole. It has a lot of, rust mechanics here and there that could, sort of derail the whole live stream. I don't want to like go deep into a Rust concept, but it basically uses the idea of, bucket sort and all that. So for this, like I said, okay, so someone asked the question: is there a way to stop? So this is from, the previous. So that's basically okay. So the way we stop it from randomizing is, when you sort it, right? When you sort it by, the we sort it in, descending order, right? This is speaking to the last this thing that we just saw, which is the top k frequent element. But let's just continue on this one. So now I'll go ahead and I'll comment out, the function and all. So I'll comment out these guys. So I'll take out this. So the simple way, to solve this, there's a very simple way to solve this, right? And the simple way to solve this is using, double nested for loops, right? So we can do something like this. Let's say for I in I don't think we don't need that. And for j in 0. Okay. Right. So at this point, what we want to do is we want to, check if I is equals to j, right? So I want to say if I is not equals to j, we want to go ahead and do something. But before that, we want to, so let's say let's mute product of, let's say prod equals to, equals to 1. We want it to be 1, right? And at this point, we then want to say prod multiplied by norms norms j, right? So I want to multiply at every point in time, and we now have to push that into somewhere. So what that means is we need a hash map, right? So we import a hash map. Say use std collections, and we say hash map. So here we just say let new map equals to hash map dot new. All right, so here we'll then push into our map, right? So we'll now say map dot push, want to push in the product, right? So at the end of the day, we just want to return okay, let's just call it our map. Just want to return our map here. So I'll comment out this guy. So let's run this and see what happens. So run this. Okay, we have, oh, I see. Supposed to, sorry, dot length. Map dot push. Okay, I have to define the type. I don't know how I always keep forgetting this. So it's going to be a hash map of is it a hash map? Do I even need a hash map? No, I don't. I don't need a hash map for this. Crazy. I don't. I need an array. That was a mistake. Sorry guys. What I need here is an array. So I need a vector. This is what I need. So not a map. Crazy. I don't know how I made that mistake. So I'll run this again. Let's see. Okay. So map not found. Yeah, of course. There is no map. What we have now is an array. Of course. So now we have, I don't know why I made that mistake. It's quite funny. Okay. So this is all we have, right? So this is like the brute force approach. Like this is an O of n squared, right? So we have like two functions, one at the index of I at the index of 1. Then we have both of them are starting at the same point, right? So whenever both of them, right, because the way it works is J runs the entire length of the array before I moves another index. J then runs another complete length of the array before I moves another index, right? So that's why we are able to do this comparison here, right? So at the point where I is not equals to J, we want to go ahead and do all the multiplication we want to do. I get the product of that value and push it into our array and return it. So this is like the brute force approach, right? Not going to really waste much time explaining this. So this is brute force solution. Guys, please remember, you can ask your questions. Always ask questions. I'll try my best to respond to those questions. Anyways, so that's like the brute force, right? So now, how do we like solve this in a way that we take it from this very crude solution that we have to something more optimal, right? Something more of like say something that is more optimal. And the way to think about this is, what if we move from the right, right? We move from the right of the array. So we move from, let me comment this out first. Oh, crap. Man. So I'll call this. So what if, for instance, let's say we have this guy, right? We have this guy. I always like to keep it here so it's close to me when I'm doing my illustration. So what if we do a pass where we loop through this array once, moving from the beginning till the end, right? So if we do that, would have would have the value of, I think for this particular one, have the value of 1, 1, 3, and 6, something like that, right? Because we will not get to the end of this. Then we'll then loop this again, but this time around we'll reverse it from the back. Right, to reverse it from the back. So we'll go from 4, 3, 2, right? And in doing this, at every point that we are doing this, we are still calculating for the product, right? We are doing it in we are calculating it in in place, right? Rather than maintaining two different arrays for it. Right. So this would make sense when I start writing the code, because I would walk through this like step by step, one after the other. All right. So now the first thing we'll do here is, for this, right, we need first of all we need an array. So we'll say let's mute, let's just call it an array. And in this our array, we want to pre-populate it with ones, right? So we say 1, and we want ones that have the the same length with our integer of array, so same length with this guy that we are passing in. So what we'll do here is we'll just go ahead and do something like, let's say nums.length. There are cleaner ways to do this, right? To do this particular stuff, I could just declare a variable n and pass it here, but for the purpose of being very, very crude and walking through the code step by step, so I understand everything that is happening. So the first pass we'll do here is, let's say, because we'll move from left. Then when we move from left, we'll get that array. We'll then move from right and get the array again, right? So the first thing we'll do, let's say we have left, let's mute, say left be equals to 1. So we have to initialize it by 1, because if we don't initialize it, if we initialize it by 0, anything multiplied by 0 is 0. So we have to initialize by 1, simple mathematics. So now, like I said, we have to move from the left, right? So we say for I in norms dot length, right? So this is what we are doing. So very simple, right? Very simple. So at this point, what do we then do? So we want to, at every stage, we want to update this array, right? So we want to say array dot the current index, which is the index of 0 right now. So we start from 0, move from 0 to 1 to 2 to 3, right? Okay. So we'd say it is equals to, left. So right now is equals to left, and left is 1, right? Good. Now, after that, we want to compute a new value for left. So we say left multiplied and equals to our norms. So, the number in our array that we are like this vector. So we want to say I itself, right? So now, before I go ahead and I write the second part of this, which is the reverse or the opposite of this, I want us to like go step by step to understand what is happening here, because it is paramount that we understand what is happening here, right? So for the index of I, we would have something like this. Okay, let me just show the code. So I'll say print line what am I going to call this? Vowels at every stage. So let's just call this lefts, right? Let's call it lefts. Let's see what left is. So let's see what left is. We'll still come back to change it to something else. So we have left, and let's see what it is outside. Okay, comment this out first. So let's run this and see. So when we run this, use size as an iterator. Oh, I see. I made a mistake. So it has to be this. Who is making that mistake? Crazy. Expected a use size, found an I32. Interesting. Let me see. It's crazy. Okay. So we're having some errors here. So mismatch type, expected an integer, found a vec. Okay. Yeah, of course you can always come back to to watch the you can always come back to watch the live. It's also like I'm also streaming it at the same time on YouTube, right? So the live is always here on X for you to watch anytime you want. Okay, so back to it. Okay, so we have left no implementation for use size of X. Okay. So what's giving us the use size here? We need okay. Um Crazy. What's happening? Okay. So we have a mismatch type. So we expected an integer, found a vector, mismatch type, expected a use size, 970. Okay, let me comment this out first and see. Yeah, although I know that will not be the issue though. So fix this first before. As let me see, as I32. Let me see, I think so there's a problem with that's one thing I hate about using this Rust playground. There are a lot of discrepancies, compared to when you do this thing on LeetCode, right? So most times when I come back to Rust playground to do it after I've done it on LeetCode, it's always you know they're completely different environments, right? They are different environments. So sometimes you get thrown off. So the issue here is that what we had in our vector, where it was being seen as a U size instead of an I32. So, let me try and see. All right. So now let me log this guy. See, our error is gone. So you can now see that we have, 1 again, 2 and 6, right? So how this happens is this, right? So when the index of I, when we are the index of I, right? So when we are, at position 1, right? Left is 1, right? So what we are doing is that we are updating this array in place. So we are updating that array. So we are saying whatever value that is at the index of, so let's say, for instance, what we have here, so what we have above is something like this: 1, 2, 3, 4. Remember, the reason it's 4 is because the length of the array that we are passing into the function is, we have 4 values in that array, right? So that's why we have 1, 1, 1 inside here. That's what this thing means, right? Now, what we are saying is whatever left is, which is 1, we want to, replace, like, take left and place it into this array at that position. So we are doing that in place, right? So now what this means is we are saying inside this array at that particular index, so at the index of 0, place 1 there. So that's why we have, the first value is 1, right? So now after that, we now have to compute something and update left. So we now go back to our initial array, right? At index of 1 for this our original array, we have 1. So we're now saying 1 multiplied by 1, right? We're now equating it to left. So left still becomes 1 again. So that's why we have the second one here, right? So now, before I get to that, we move to the index of 2. Sorry, the index of 1. We move from index of 0 to the index of 1 right now. So at the index of 1, we are now placing this guy, right? So we are now placing this guy, which is left at that position, index of 1. And he is still 1. Remember from our past calculation, right? 1 multiplied by 1 is 1, right? So now we move again, right? So we come here, we do our calculation again. So now left is still 1 here. But who do we have at the index of 1 from our original array? At the index of 1, we have 2, right? So we're now saying 2 times 1 is going to give us what? 2. So we're updating left. So left now becomes 2 at that point, right? So at that point, we now move to, the second index of our array. So at the second index of our array, we move to that second index. Left is 2. Left now updates this 1. So this 1 now changes from 1 to 2, right? So we now have 2. Then we now come back again to do our calculation. So left now is 2 at this point. Now, remember, we are still at the index of 2. So what do we have in our original array at the index of 2? We have 3, right? So norms I here at that index of 2 is 3, right? So 3 times 2 gives us 6. So, so it gives us 6. So we go ahead to update left as 6, right? Then we move again, right? We move to, to the last position in our array, which is at the index of, 3. So now at that point, left is already what? 6. So we go ahead to update that last position in our array. We update it to 6, right? So when we update it to 6, we come back here, we do our calculation. We already have 6 here, right? Then we check what is norms I at the index of 3 is 4. So we do 6 times 4, whatever number we get, to update it here. But now we've reached the end of that particular that array, so we don't go ahead to update anything again. So that is how we are able to get 1, 1, 2, and 6, if that makes sense. So I'm just trying my possible best to like really break this down and explain it so that it's easy for you guys to understand. So if I even go ahead and say, for instance, if I go ahead and log the array, so I said I was going to log, let's say, our array. So I would log our array at this point, right? So I'll just take out this guy because we do not need him again. He has served this purpose. We've seen what is happening inside our loop. So now if I run this again, you see what we have. So you see this is exactly what we have. That's what we just traced here. So we have 1, 1, 2, and 6, right? So that's what we have. So now we've gone from the left to the right. How do we then go from like the right to the left, which is basically flipping what we have, right? Flipping it and doing it like reversing it basically, right? So it's basically the same thing. There is no much difference in doing that. The only difference is we now have to do like our calculation in place as we move from right all the way back to the left, right? And it's the same thing that happens. And I'll still try my possible best to like sort of illustrate it, right? How many? Okay, this is an hour, 15 minutes. Okay. So now, okay. So the next one, what we'll do next, so I'll take this out or I'll just comment it out because I might need it later on. So at this point, right, we have already computed from the left to the right. So now can we then compute from the right to the left and at the same time get our products in place? Is that something that we can do? Of course we can. And how do we do this? It's the same, like almost the same thing, right? So what we do at this point, we say let's mute because we are moving from the right be equals to 1. And the reason why we are using 1, remember, like I said, we are looking for the product of values. If we use 0, anything multiplied by 0 is 0. So we have to like use 1, right? Standard mathematics. So if we do it again, say for I in num 0 dot nums dot length, right? So this is a Rust specific thing, right? So how do we then, start looking from the right hand side? Other languages like JavaScript, Python, Go, they all have the ways that, their ways of doing. That's why I said everything we do here is something that is applicable to these are data structure algorithms. So you can take these concepts and go and apply them to your own language and stuff. So now we have to reverse, right? So you would have to look for a way you do your reversal in JavaScript or TypeScript or JavaScript and TypeScript is the same thing, right? Python, Go, the rest of them. So now the way we do this here is we now have to like there's a keyword we call the rev keyword. So we'll wrap this, then we'll now say dot rev. So this would like do it from the back, right? So we'll start from the back and we'll start doing the multiplication, right? So at that point we'll do something like this. So now it's the same thing, right? So we want to still say array dot I, but there's a catch because we want to do this in place. So we'll be multiplying here. So we say, so instead of just equating that value, we are going to multiply the right before we do it. So we say right, and we say right again. So multiplying the value on nums I, right? So now if we go ahead and log what is happening here. So this is going to be a little bit tricky, sort of, different from the previous one. But then I'll try my possible best to like break it down. So, but before we go on, right, what exactly is happening here? So now, because we are starting from the right, we are starting from here, right? So we have the right at this point is 1, right? And because we are reversing, we are starting from the index of 3, right? Remember, this is what we have currently in our objects. Sorry, in our array, right? This is what we have, right? So we're starting from the back here, the end of the right of this. We're moving all the way backwards like this. So since I is currently at the index of 3, right? So array.3, what is array.3? Array.3 is basically 6, right? And we know that I here, right, is 1. So 1 multiplied by 6 is going to give us 6, right? So that's basically what we are going to write to that position, right? Now we'll go ahead and we'll do our. So this is where we are updating, to get the actual value or the actual, product of the array except itself. This is where we are getting it in place. Like this is sort of like the most important line, in the whole code, right? Then we go ahead to do the similar thing that we are doing in the first function, right? So we know that right is still 1. So we come here, we say, right is 1. So at index of I, nums I, what is at the index of that? What do we have at that index? What we have at that place? We have, what do we have at that place? We have 4, right? Which is because nums 3 is 4. So what we are going to do is 4 times 1, right? We update it. So this becomes, this becomes 4, right? So we move it again, in like as we keep going back. So now at the index of 2, we are inside our for loop. So this is right is 4. What do we have at the index of 2? What we have at the index of 2 is 2, right? So 4 times 2 will give us, 8. We update it at that position. So 2 now changes to 8. So this changes to 8, right? So now remember, right is still 4. So we come down here, we do our calculation. So 4 multiplied by, what do we have at the index of 2 is, 3, right? So 4 multiplied by 3 gives us 12. So right now is now 12, right? So at that point, we have right as 12. We move again, backwards to, you know, the index of 1. So at that index of 1, we check, right now is 12, right? So 12 multiplied by what we have at the index of 1. What we have an index of 1 is just 1, right? So 12 multiplied by 1 gives us 12. So we go ahead and we update it in place. So we have 12 there. Then we go ahead to do our calculation, right? So our calculation, remember, right now, inside this our for loop, in that same iteration, right is 12, right? So what is the norms of I at index of 1 from our original array? It is 2, right? So if we do 12 times 2, then gives us 24. So we update right, and right becomes, 24. Then we go to the ending of the array where right is, 24. 24 multiplied by 1 is 24. We update it. We do that calculation again, and all we update the right. And because we've gotten to the ending of that array, we can no longer, update anything. And that gives us our final answer. So at the end of the day, we then have, 24 here. So I know this is sort of, it's kind of complex to, reason about for the first time. But, the most important thing to take note of here is the fact that, we are reversing the array and doing the same thing that we did in this one from the back, right? The only difference here is that we are getting the product this time around and we are, updating the array in place. So I don't think there's any need for me to, run any printing or stuff, but I'll just go ahead and, say, okay, let's just do that. So inside here, we have, let's call it right. Let's see what right is at every point in time. So I'm saying, right. Let's see what right is at every point in time. So let's run this. So you can already see, right? We already have like 24, 12, 4 and 1. And I kind of understand why, it's like, because we are still inside, this array. So let's see what happens if we, do this outside. So instead of just right, let's do, no, let's do this here. Let's see what right is at this point. Crap. So you can already see, right? We have, yeah, this is not what I expect. Let's do this, run this. Let's see. Yeah, so the last value is 24, of course. So if we try to do our array, say our array should give us 24, 12, 8, and 6. Hopefully. Exactly. So you can already see that it gives us 24, 8, 24, 12, 8, and 6, right? So you can just go ahead and just return the array itself. So just say array. So I'm returning it. Of course. So I'll just clean off. Okay, I'll leave all these ones. Take out this, just make the code clean. Take out this guy, and let's run it again and see what we get. So yeah, so you can now see that, the optimal solution, right? So we have 24, 12, and 6, which is, what we expect here. If we test it with this solution, with this example, let's do this example. Let's see what we get. So let's run it. Exactly. So we have 00900. So check what exactly. So this is what we expect. Same thing would have still worked for, the brute force, solution. So yeah, that's basically how this works. Feel free to ask me questions if you have any, confusions or places you need me to, like, clarify and stuff, right? And I would, answer those questions. I'm trying to go through the live stream to see if there are any questions that I can respond to. Okay, a couple of people. All right, so this is it, right, for the second question. So we'll go over to the third question, and after that we'll call it a day. All right, so I will just close this, sanitize my environment. All right. So the last one is a very interesting question, right? It's the Sudoku problem, the valid Sudoku problem. So it's basically saying, determine if a 9 by 9 Sudoku board is valid. Only field cells need to be validated. So basically saying each row must contain the digits 1 to 9 with no repeats. Same for the column, no repeats. And each of the 3 by 3 boxes must contain the digits 1 to 9 with no repeats. So this is like one of the most, difficult of all, like one of the most difficult question. Well, I will not say it's difficult, but I would say it's sort of hard to explain. But I'll try my possible best to explain it, right? I've been talking since. Let me drink water. Okay. So think about what we have here. We have a Sudoku board. For those of you that are familiar with the whole Sudoku game stuff, right? We have a Sudoku board, and in our in this Sudoku board, right, we they are saying that we need the rows. These are the rows, right? We need we don't need any repeat values, and it's a 9 by 9 board, right? And guys, I'm sorry, I forgot to to mention the complexity of this. This is an O of n. So for the previous solution, right, it's an O of n time complexity, an O of n time complexity. But back to our valid Sudoku. So, as I was saying, this is one of those questions that they're not really that difficult, but explaining them deeply for one to really understand is challenging, right? So I'll try my possible best to explain, to the best of my ability, and let's see how that goes, right? So now we have a board, a 9 by 9 board, and what this means is, we have um these are the like basically the rows, and this would be the columns, right? So from the top to the bottom. Then the 3 by 3 is everything in the first 3 box radius, right? So we have, for this case, we have 3, 5, 3 full stop. We have 6 full stop, and we have full stop 9 and 8, right? So that will be our first like our 3 by 3 is going to be our 3 by 3, right? So you're saying that we should make sure that there are no repeat elements in any of them, right? So how do we solve this? So first of all, let me comment out this. Okay. So now, in order to to solve this, we have to think of like I think one of the ways I try to like solve this is the fact that I have to like think of how can I move through this board efficiently, right? As efficiently as possible, right? Because um this is one of those solutions where I think the optimal solution is an O of n squared, right? Because we need to, this is a like sort of like a 2 by 2 board. So we need to, be able to, you know, move through it as such. Now, when they say then when we talk about not having a duplicate, we already know that we already know we're talking about like something like set theory, right? I already added hash sets here at the top, so I'll just comment it out. So we're using hash sets to maintain uniqueness between all those elements as we go through them. So we'd have 3 different hash sets. We have the hash sets for rows, we have hash sets for columns, and we have hash sets for the 3 by 3 itself, right? Then from there, it's just basically simple, right? It's just basically simple from there. But one thing I would do in this one is I would try as much as possible to do a lot of console.logs to show you guys how we move through, how we move through this particular Sudoku, right? And, I'll show you guys how we move through the Sudoku itself to sort of, make it more easy to understand, basically. All right. So in order to solve this, we're going to use 3 different hash sets. So I'll take this out. I'll say, let's we call this one rows. Going to be a hash set. Okay. Of strings. A set of strings. So let's see. Not really, but we want a vec. So that hash set is sitting inside there. Okay. So now, what next? So we want a vector that contains a hash set. And we want it to have 9 positions. Remember, it is a 9 by 9 fixed box, right? And like I said, the solution that I'm coming up with, I'm going to be solving, it's, the space complexity is an O of 1. In case you'll be wondering, okay, how is it an O of 1 when we have multiple hash sets? It's because the data that we are passing into the function is constant, right? It's a 9 by 9. It doesn't increase, it doesn't reduce. So it's a constant, number. So it's not like it grows exponentially, right? So it's going to be an O of 1 space complexity and an O of n squared time complexity, right? But that's by the way. So we have this. So we're basically, declaring a hash set with, that has like 9 values, like capacity of 9, right? 9 values in it. So we'll just copy, duplicate this for the sake of time. So I'll call this column calls, and I'll call this group. All right. So this is basically what I want to do. So now, in order to move through this particular arrays of array, because that's what this is, right? It's an array of nested arrays. In order to move through it, we need a double nested for loop. So we say I want to move from 0 to 9. And we'll call this j. So I here represents our rows. So I would move like this, while j, would move, from top to bottom. So basically from like columns, right? Like straight down, straight down, straight down. So I'll explain what that means. So in 0 to 9. All right. So first things first, because this is a 2 by 2 board, right? A 2D board or 2 by 2 board, we have to come up with a way to get a single value, right? And how do we get a single value? We have to target both the rows and the column at the same time. So how we'll do this, we say, let's the value be equals to what are we passing in here? It's norms, right? So say norms I and j. So before we go on, if I log this, let's say I log not log, print val okay, so val, so you see that it will give me each value in our array of arrays, including the the ones that we don't use, are the full stops, right? These guys. So let me run this and see what happens. Run. So you can see what we have, right? We have a lot of them. So it gives us each and every one of those values, right? So the next thing we have to now start thinking of is, okay, since we have all these, and by the way, don't mind, these are just warnings. Since I've not used, like saying like I've not used rows, I've not used columns, I've not used group, stuff like that, right? Anyways, let's continue. Let's continue. This is intentional prefix. Okay, yeah. So it gives me all this, right? But the question now is, how do I ignore the guys I don't need? Because the question basically says wherever you see something like full stops like this, you should automatically know that, you should automatically know that this represents the fact that there are no values there, right? So how do I take that out? It's easy. So I would say if value is equals to, mhm, I just want to continue, right? So to continue basically. So to skip it. So let me run this again. So now we'll have a clean output. So you can now see that we have a clean output of numbers in our array of arrays or vector of vectors of strings or string slices or whatever it is that we want to call them. Right. So we have these guys, right? So now we are catering for both at some point we are catering for both the the rows and the columns, right? But now what happens if we say for instance, right? um we want to get the 3 by 3 board, and this is like a mathematical stuff, right? So in order to get that, we have to take I, which is the rows, and we divide it by 3, because remember the question says 3 by 3, right? And we multiply it by 3 again and add it to j divided by 3. So that particular formula is what is going to give us like the 3 by 3, a 3 by 3 board, or a 3 by 3 set of data in this particular board. So it's going to give us 3 by 3, 3 by 3, and 3 by 3. So another one from the middle, and another one from the bottom. So we have the ones on the left, everything like this to the left. We have the middle, and we have the ones to the right. We have the ones at the top, we have the ones at the middle, and we have the ones at the bottom, right? So that's basically how we'll try to separate it. So in order to achieve that, let's just say let's group PRD group equals to, so this is the mathematical calculation I was talking about. So I divided by j, sorry, divided by 3, because I want like 3 by 3, multiplied by 3, multiplied by 3 plus j divided by 3, right? So let's log this and see what we get. So okay, let's see what we'll get. I've not tried that before. Let's just see what it gives us. So it basically gives us like it gives us a 3 by 3 of like 3 by 3 value, right? So we have 0, 0, this is 3, it's 4, 5. So we have 1, 2, 3, 4. Which other place again? Then out of 3, out of 2, we have 2. So this is basically like the index, right? But if we are to do something like let's say something like val, do something like this. Let's see what this gives us. Okay. That breaks. No, that's not okay. Let me see. I'm just at this point. I'm just experimenting to see what we would get. I'm not sure any of this. Okay, so we have um. So we have the first. So these are the first index. So we have 3, the top, the middle, and the the bottom. So if we go back to the actual data that we are passing in, you can see we have 5, 3, and a full stop, right? This is it, right? We have this. Then the next one we have is we have a full stop, 7, and dot. So this is like moving from the rows all the way to the last part. Then we have 5, 3. This is interesting. 5, 3, 7. Is it repeating itself? Okay. So I will just let me take this out, right? We'll come back to the whole login and trying to make sense of how the flow of data works. Right? We'll come back to that. So I'll close this out. And the next thing we have to do now at this point is remember we declared a hash set, right? We declared a hash set. So this hash set is going to help us to make sure that the values that we are passing into our function, that they are all unique, right? From the rows to the columns and like the 3 by 3, right? So in the case whereby we meet any invalid, any duplicate number, hash set automatically return false for us. So we'll do this in one straight line. So we'll say if not row, so row, remember I said row represents like you know the horizontal flow of data, and that's what I is, right? So we'll pass I dot insert. Remember it's still a hash set. So at that point, we want to insert the value, right? So that's what we want. Insert the value, or we want to do the same thing for the column and the group. So we'll copy this, just copy this for the sake of time. So we'll change this to, it's not row, it's rows. We'll change this to column, and we'll change this to, what's it called? Group, groups. And this will change from I to J, right? Because J is for columns, and this will change to board group. So it's no longer I or J, but board group at this point, right? So let's go ahead and at this point, let's log. Would also print, not log, always saying log. So I'll also print what's it called? Rows calls column. Just trying to make sense of the data and group. So this is our 3 by 3 group. So this gives us this. Rows, columns, and groups. Okay. So if that is the case, you just want to return false, right? So if any of that, right, because that is the case, just want to return false. Else we want to return true here, right? So which is something we're already doing. So let's run this and see what happens. Hopefully everything goes well without any breakage or bugs. Of course, everything cannot go well. Okay, so there's an issue with how I am. Okay. So let's run it again. Okay, so this gives us, of course, it gives us true here, right? But now let's take our time to study the data. There's a lot of data here, a lot. So we have like rows, and I guess it will go on to groups. You can see the groups, and then we have columns and all, right? So, but first, let's start from our rows, right? So if we take a look at our rows, you can see what's happening here. So we move. If you look at the main data, right, the first row. So we move from what? We check for like duplicates in this row, right? We check for it like this, like I explained initially. So we move from 5. The next time we added 3. The next time we added 7, right? That's the only values that we have here. The rest are just invalid properties that we automatically took off when we did this, right? So that's it. So there was no duplicates for these guys. Then we move to the second row. So the second row now, you can see it here. 6 started with 6, right? So we have 6. The next one we're going to have 1. So you can see 6 and 1. Then we have 9, 5, and nothing else. So we have the next one was 6, 9, 1, and we have 9, 5, 1, and so finally we now had our 1, right? So this is where this guy ended, right? Now let's go again. So the third row, these guys, so we'd have 9, 8, and 6. The rest are invalid. So we started with 9. So as you can see, 9. We have 9 and 8, and we have 9, 8, and 6. Right? So we'll go to the fourth row. So for the fourth row, what do we have? We have 8, 6, and 3. So we started with 8. You can see it here. We started with 8. So we have 6, 8, 6, and we have 8, 6, and 3. Right? 8, 6, and 3. So now we move to the next one, which is the fifth row. So we have 4, 8, 3, and 1. So we started with 4. We have 4 and 8. 4, 8. So we have 8, 4, 3, of course. We have 8, 4, 3, and 1, which is the last one, right? And it ends there. We move to the the next one, which is starts with 7. So this row, the fourth to the last row. So we move to this guy. So 7, 2, and 6. So we have 7, 7, and 2, and we have 7, 2, and 6. So we move to the third to the last one, which is 6, 2, and 8. So it starts with 6. You can see it here, right? So we have 6 and 2, then we have 6, 2, and 8, right? Then we move to the second to the last one. So we have 4, 1, 9, and 5. So it started with 4. So you can see it's 4, 4, 1, 4, 1, 9. And we have 4, 1, 9, and 4, 1, 9, and 5, right? Then the last but not the least, where we have 8, 7, and 9. So we started from, you can see it, this is 8, 8, 7, and 9. Then next we move over to the columns, right? So now if we go back to the top again, go back to the top. So this is where the columns started from. So this is where the columns started from. We have what's it called? Okay. So we have 5. So next we have 5 and 3, 5, 3, and 7. Okay. Then we have 5. So the way it works, right? We have 5 for our first column, right? So we move all the way down. We move to the next column because this is the next column. So all the way down we have 3, right? So if we move another step down, we now have, if we move another step down from like 5, we now have 5 and 6 for the first column. So this is it, 5 and 6. We still have 3 at this point, right? Nothing in the next column dot. So we have 1, right? We have 1. So what it does is, for the column, right, it moves all the way. So it tracks for the first elements. For the first elements, then it moves all the way down. It keeps going like that, right? So as we keep going, you see that we now have 6 and 5. This is 5 and 6. If we check down again, at some point we'd have 6, 5, and 8. So this is it, right? So we have 6, 5, and 8 here, right? So you can see it's going down like this. So at some point we will have 6, 5, 8, and 4 with 7. So we have 6, 5, 6, 5. So we have 6, 5, 8, 4. So let's look for where it ended. We have so this is where it ended, right? So this is 6, 5, 8, 4, and 7 for the first column. So this is where it ended. Right? So this is where that guy ended. So this is it here, 7. All right. So let's move to the second one, which is 3, 9, and 6. So we have, you can already see here we have 9 and 3. So let's look for where it ended. You can see it here, 3, 9, and 6. So this is how it keeps going and going. I'll not go into the group because it gets really, really complex. For the group aspect, right? What we are basically doing for the group for grouping is we are basically, triangulating the, something like 5, 3. There will be nothing here, so we'd have 6. There will be nothing in these two places, so we have 9 and 8. So it's basically 5, 3, 6, 9, and 8. So if we search for that, so we'll see, um, this is it, right? 5, 6. So this is it, right? This is for the group. Right, so we've grouped it here. So we have 5, 6, or 5, of course, 5, because they are still the same 3 by 3 box. So 5, 3, 6, 9, and 8, right? So we can continue doing this for the rest of them, right? It just gets really tricky, and it's a lot, right, to wrap your head around. But it's quite easy to solve once you sort of understand the mechanics around it. Anyways, if we, for instance, let's do some duplicates, right? Right now we are getting, let me comment this out. So right now we are getting, when we run this, we'll get true, right? Because there's no duplicates, right? There's no duplicate. But if we say, for instance, let's say we add 9 here, we'll automatically get false because, of course, right? We'll automatically get false. Anyways, guys, so this is basically it for today's stream. And of course, like I said, the time complexity for this one is an O of n squared. Basically because of we have like double nested for loops. The space complexity is an O of 1. The reason it's an O of 1, despite the fact that we have initiated 3 different hash sets in memory, is the fact that it is static data, which is a 9 by 9 Sudoku that was passed into our function. So it doesn't, like, the values do not increase over time as as we go on. Anyways, guys, so I think with this we've come to the end of today's live stream. Let me know what you think. Feel free to drop your questions. You can send to my DMs, whatever, right? Just let me know what you think about this, and hopefully I will see you guys next week for another live stream. Peace.